Now we have a data sufficiency question, and the question is asking whether x is less than y or not. The answer of the question needs to be given in the form of either yes or no. First statement. Now, here comes the data sufficiency rule, which is our intention should always be to prove the statement is not sufficient. So we have to think about the possibilities of x and y which satisfy this statement but give inconsistent answer to the question. So one possibility that I can think of which is very easy is I can choose x equal to 1 and y equal to 2, because 3 raised to the power 1 is less than 2 raised to the power 2, and x is less than y, which means answer to the question is yes. It was quite simple because their bases are positive, and if x and y have to be positive, in that case x always must be less than y. But the scenario might change if we can choose x and y to be negative as well. Therefore, the second case I am planning to choose is of the negative values. For example, if I choose x equal to minus 2, then this becomes 1 over 9. In that case, the value of y can also be chosen as negative 3, because 3 to the power minus 2, which is 1 over 9, is still less than 1 upon 2 raised to the power 3, which is 1 upon 8. Whereas if you see x and y, then minus 2 is greater than minus 3. So answer to the question in this case, considering this case, is no. Inconsistent answers, therefore we can say that the first statement alone is not sufficient. Having said that, we can eliminate two options, which are A and D. Now comes the second case. The second case does not tell us anything and is clearly not sufficient because of the reason that it simply says that x and y both are positive. But we can't compare whether x is bigger than y or not, therefore not sufficient, and B option can also be eliminated. Now the third step is combining the two statements. After combining the statements, what we understand is, because the second case has ensured that now we can't choose the negative values of x and y, which means 3 to the power x must be less than 2 raised to the power y, where x and y are both positive. And under this scenario, because x and y are positive and the base of 3 is bigger, therefore x must always be smaller in order to satisfy this, and hence we can conclude that for both the conditions to be true, x must be smaller than y. So together it gives us definite answer sufficient, and hence answer to the question becomes option C. Thank you so much.